Hello everyone. Today we are going to start our journey in dynamic models. In the first part of the module, we focus on static models where decisions only affect the current period. However, many economic activities are intertemporal, involving both current and future periods, such as savings and investment. Models with intertemporal decisions are called dynamic models. Let's summarize what we have done up to now. To explain business cycles in the labor market, we developed three types of static models. The first is the classical and neoclassical models. They mainly explain business cycles from the supply side. However, there are two failures. They cannot explain extreme recessions and the extensive margin. To resolve the first limitation, Keynesian and the new Keynesian models introduce imperfect computation and nominal rigidity and emphasize the role of the demand-side factors to explain business cycles. This part will be detailed in the next part of the module. To resolve the second limitation, the DMP model introduces search and matching friction and Nash bargaining to explain the business cycles of the extensive margin in the labor market. Now we are shifting our focus from the labor market to the other input market, the capital market, and the credit market. The two markets here, credit market and capital markets, are closely related and effectively two sides of the same coin, because the capital market is about investments from the firm's perspective, and the credit market is about savings from the consumer's perspective. The common feature of the two markets is that decisions involves both current and future periods. Models to explain these intertemporal markets are dynamic models. Look at this big picture of our models. We are now in the dynamic version of the RVC model. For simplicity, we start with a simple dynamic model without a labor market, but as you will see later, a complete RVC model with both labor and capital markets maintain all conclusions of the separate static and dynamic models. First, let's start with some stylized facts of the capital market and credit market. As we have seen in lecture 0.1 and 0.3, the volatility of investment is greater than that of output market. Investment is also procyclical because it has a high positive correlation coefficient of 0.8 or 80%, which means that 80% of the time, investment moves in the same direction as the output. Finally, the response of investment in the capital or credit market has a hump shape after a macroeconomic shock. It implies that investment adjusts slowly and the effect of shocks is persistent. Specifically, if we distinguish non-durable goods consumption from durable goods consumption, we see two different patterns. The volatility of non-durable goods is much smaller than that of output, which is what we know as consumption smoothing. This makes sense because you don't want to starve when you are in deadlock. So people usually use the credit market to borrow to smooth their consumption. In contrast, the volatility of durable goods exhibits excess variability. In fact, the durable goods resemble investments closely. It is because durable goods, such as cars and houses, behave much like investment, since durable goods can be a store of value. As a result, if there is credit rationing, the access to the credit market can be limited to the poor. The poor becomes even poorer, and the rich becomes richer. Another mechanism to magnify the excess variability is coordination failure. It is when your investment is motivated by investment of other people around you. This is a common phenomenon in the stock market, where overshooting prices occur all the time. If you are interested, you can take a look at the coordination failure model in topic 3. The four graphs on this slide show the two starlight facts of the business cycles in the credit market or capital market: the excess variability of durable goods and consumption smoothing of the non-durable goods. It is shown in the lower right figure that non-durable goods and stock prices are positively correlated, suggesting that non-durable goods are better treated as investment rather than consumption. Now that we summarized our question, that is, the decisions in the credit or capital market. In these markets, decisions are not only relevant to the current period, but also relevant to the future period. That is why these decisions are intertemporal in nature, because you effectively face a trade-off between today's consumption C and tomorrow's consumption C prime. The decision linking the two consumptions is savings S. It is mathematically generic to the intratemporal decision, which is a trade-off between today's consumption C and today's leisure L, which is linked by the labor supply NS. The question determines the method. Given that we are trying to explain business cycles of the credit or capital market featured with intertemporal decisions, we must employ a dynamic model. The techniques used in this part are similar to those used in the static models. We will still use differentiation to optimize for individuals and use equation solving techniques to obtain the equilibrium. Note that these two sets of techniques are always used in micro-founded macroeconomic models. Looking at the graphical exposition of the simplified dynamic model, this lecture starts with an exchange economy, where production is ignored as a whole. In other words, firms do not exist, and consumers get their income all by chance. This is the simplest model we can have for a dynamic model without reducing the explanation power. In a more complete dynamic model to be introduced later on, we will have firm as well. For now, we only have consumers, and the lucky endowment-rich consumers are lenders in the credit market, while the unlucky endowment-poor consumers are borrowers. In addition to individuals, the government also participates in the credit market, demanding for credit at a certain interest rate. This interest rate is usually lower than the interest rate facing individual consumers for its lower default risk. Banks are intermediaries linking lenders and borrowers by charging an interest rate spread between the lenders and borrowers. The rest of the model is the same as before. There is an output market, but the supply side is now assumed away to be exogenous. The first learning objective is to know how to set up a simplified dynamic model, and then you must know how to transform two budget constraints into one lifetime budget constraint. Based on that, you should be able to derive the intertemporal condition, both in mathematics and in graphs. Finally, apply the dynamic model to explain the stylized facts in the credit market during business cycles. Now let's look at how to set up the simplified dynamic model for the credit market. Again, we adopt the micro-foundation method in the new classical tradition. All optimal and equilibrium conditions are derived from microeconomic principles. Like the static model, this dynamic model is a simplified version of the real business cycle or RBC model. Let's summarize the assumptions of this simplified dynamic model. Without losing generality, we only consider two periods because a dynamic decision usually affects two periods only. So there is a current period and a future period. For simplicity, there is no intratemporal decisions to make, so labor is fixed at 1. This is just like in the static model where capital is fixed at 1. Given that there is no production or no firm, consumers are both supply side and demand side of the credit market. The endowment-rich consumers are the lenders who are lucky to have a higher income, and the endowment poor consumers are the borrowers who are unlucky to have a lower income. To make our life easier, we are going to use the following notational conventions. Lower cases are used for individual level variables, such as small y. Upper cases are used for aggregate level variables, such as capital Y. A variable with a prime indicates that it occurs in the future, such as y prime. Like the static model, we model the decision of the consumer by an objective function and constraints. In the static model, the objective function is utility, which depends on two goods, consumption C and leisure L. Similarly, in a dynamic model, the objective function also depends on two goods, current consumption C and future consumption C prime. Therefore, mathematically, the dynamic utility function U of C prime is the same as the static utility function because it's a function of two inputs. The only difference is that the two inputs has changed from C and L to C and C prime. Graphically, it is again a three-dimensional surface or a two-dimensional indifference curve. The slope of the indifference curve is the marginal rate of substitution between C and C prime, or the ratio of marginal utilities of C and C prime. Like all new classical models, the marginal rate of substitution follows the diminishing law. That is, the more you consume the same good, the happier you will be, but the increment of happiness will be less. A popular dynamic utility function is logarithmic, shown here. The coefficient in front of the log of future consumption, beta, is always less than 1 and greater than 0. It is the subjective discount factor of utility in the future. It measures patience of the consumer. If the beta is lower, that means you put a lower weight on future utility in your lifetime utility function. Now let's turn to the constraints. There is no labor decision, so there is no time constraint. But there are two periods, so there are two budget constraints. In the current period, the total outflow must be equal to the total income. Therefore, consumption C plus savings S must be equal to the after-tax income, Y minus T. Note that savings S can be negative, which means borrowing. In the future period, the total outflow also needs to be equal to the total income. The total outflow is just the consumption in the future periods, C prime. The income has two components. The first is still the after-tax income, Y prime minus T prime. And the second component is the interest of the savings, which is equal to 1 plus interest rate R multiplied by savings S. If the consumer is a borrower, then S is negative. So 1 plus R multiplied by S is also negative, which is the total debt repayment. To see the graphical intuition, we can combine the two budget constraints by substituting out the common term, the savings S. This step is simple. Express S by the rest of the first equation, and then replace S term in the second equation. After some algebra, you will be able to rewrite the combined condition in this form. The left-hand side is the sum of the present values of consumption, and the right-hand side is the sum of present values of after-tax income, which can be defined as wealth, WE. It effectively describes the lifetime budget constraint in present value terms. It is straightforward that if there is no savings, S equals to 0, then the consumption profile is stuck in the endowment point, Y minus T and Y prime minus T prime. This can be easily verified by substituting s equals to 1 into the two budget constraints. If we draw this combined constraint in the C prime diagram, it is observed that if the interest rate 1 plus r is greater, the combined budget constraint becomes steeper. Do you know why? This can be answered mathematically. Try to rewrite the combined constraint in the form that C prime is on the left-hand side as the dependent variable of the function, and everything else is on the right-hand side. C is treated as the independent variable, and its coefficient is equal to minus 1 plus r. No matter how the slope changes, the constraint always pivots around the endowment point E, because when s equals to 0, the endowment point is independent of changes in r. Now that we have analyzed the objective function and the constraints, we are ready to integrate them in a utility maximization problem. Since there are two types of consumers, the optimal choice differs. For consumers with a higher endowment, their optimal choice, A, lies to the left of the endowment point, E, so they are lenders. The current consumption, C, is lower than the endowment, Y minus T. In the future period, the consumption C prime is therefore greater than the endowment Y prime minus T prime due to the interest income. On the other hand, for consumers with a lower endowment, their optimal choice A lies to the right of the endowment point, so they are borrowers. The current consumption C is higher than the endowment Y minus T. In the future period, the consumption C prime is lower than the endowment Y prime minus T prime due to the interest payment. The graph in the previous slide is intuitive but not accurate. If you want to be a serious economist, you need to be able to solve quantitative models behind those graphs. The maximization problem of the consumer can be written in the following form. The objective utility function depends on C and C prime, while the combined budget constraint is used for simplicity. Again, you can either use the Lagrangian method or substitution method to solve this maximization problem. There are three steps, just like in the static model. First, substitute the constraint into the objective function so that there is only one endogenous variable left. Second, take derivative of the objective function with respect to that endogenous variable and set the derivative to 0. This is because only when the slope or the derivative is equal to 0, you are at the top of that function. This optimality condition, or the first order condition, leads to the intertemporal condition. Third, if the utility function is explicitly given, then you will be able to derive the explicit solution of all endogenous variables. Let's apply this three-step approach in the dynamic model. Step 1, substitution. We have two endogenous variables, C and C prime. It is straightforward to substitute C out by C prime using the lifetime budget constraint. The red term here is actually C, but we substitute it out by C prime and other terms. Step 2, differentiation. When you take derivative of the utility function, note that the utility function is a multivariate function. The utility depends on both C and C prime. If either C changes or C prime changes, the utility will change. Now that C is substituted out by C prime, a change in C prime has two effects on the utility. There is a direct effect of C prime on the utility, and an indirect effect via C on the utility, because the change in C prime will affect C, which in turn affects the utility. Therefore, we need to use the multivariate chain rule here. The derivative has two components. The first component describes the indirect effect of a change in C prime on the utility via C, and the second component describes the direct effect of a change in C prime on the utility. The derivative of utility with respect to C is just the definition of marginal utility of current consumption. The derivative of C with respect to C prime is just a coefficient of the budget constraint, that is -1/1 plus R. And the derivative of utility with respect to C prime is the definition of marginal utility of future consumption. If we rearrange this optimal condition a little bit, we have the interest rate 1 plus R on the left-hand side and the marginal rate of substitution on the right-hand side. This condition has the form of marginal cost equal to marginal benefit, just like the counterpart in the static model. Because it describes the optimal condition in the dynamic model where decisions have intertemporal effects. This condition is also called the intertemporal condition. Recall that in the static model, the optimal condition is called the intratemporal condition because it describes the optimal condition of a static decision. Step 3 is not relevant in this lecture because we do not give you an explicit utility function form. In the tutorial, you will have a concrete example where you will be able to solve all endogenous variables in terms of parameters and exogenous variables. Based on the simplified dynamic model, especially the intertemporal condition, we can now apply it to explain business cycle stylized facts in the credit market. Note that there are 3 endogenous variables whose fluctuations are to be explained: current consumption C, future consumption C prime, and savings S. There are 5 exogenous variables which can be used to explain the endogenous variables. They are current endowment Y, future endowment Y prime, current tax T, future tax T prime, and the interest rate R. To explain business cycles of endogenous variables, we need to use changes in exogenous variables. This is what we call comparative statics. We have done that in the static model as well. Now we want to see if the predictions of the simplified dynamic model can fit the stylized facts of business cycles in the credit market observed in the data. Start with the change in the current endowment Y. Recall that in the static model, an increase in income, either due to a higher dividend pi or a lower tax T, amounts to a pure wealth effect to raise consumption and leisure at the same time. Will the dynamic model have the same effect? As shown in the graph, when Y, the income, rises, the endowment point goes from point E1 to point E2. It is a horizontal shift because Y prime doesn't change and the slope Y plus R doesn't change either. The optimal choice shifts from point A to point B. The resulting current consumption rises from C1 to C2, and the future consumption rises from C1 prime to C2 prime, indicating a precyclicality of consumption. Specifically, note that the increase of consumption from C1 to C2 is the length AF, smaller than the change in output from E1 to E2, or equivalently, the length AD. This is in line with the stylized facts of consumption smoothing. Savings S, measured as the gap between endowment point and consumption point, also rises, so savings are also precyclical. In the data, the volatility of savings should be greater than that of output, which is called excess variability, but we cannot tell from the graph. To evaluate the dynamic model in this aspect, you need to use a quantitative model and solve it mathematically. For example, you can use the model in the tutorial to see how much the savings has changed relative to the change in output. Now let's look at the effect of the future income y prime. In this case, the shift of the budget constraints occurs vertically rather than horizontally, but the effect on consumption is similar. Due to the wealth effect, the consumer will always consume more in both periods. However, the savings in the current period S drops, or it is counter-cyclical in this case. The intuition is that if you know you're going to be a millionaire in the future, you wouldn't save that much today. You would even borrow today to consume because you want a smoother consumption. Therefore, we usually distinguish between temporary and permanent changes in endowment in dynamic models. A temporary change shifts the budget constraint horizontally from H to L, but a permanent change shifts the budget constraint both horizontally and vertically from H to M. The difference is quantitative rather than qualitative because you can't really tell the difference qualitatively. You can only distinguish the two changes quantitatively. Consider the difference of the temporary and permanent changes by the following two examples. Will you change your long-term consumption pattern if you win the lottery of £1,000? What if you get a promotion in your job? Obviously, if you have a windfall of £1,000, you may give yourself a treat to go to a 5-star hotel, but that is once for all. You wouldn't go there every month. In contrast, if you are promoted to CEO, then you will go to holiday every month. Milton Friedman called this the permanent income hypothesis, PIH, which states that the current consumption depends on the permanent income or wealth, WE, rather than temporary income, Y. Recall that the permanent income or wealth is defined as the sum of present values of after-tax income in your life. If an explicit utility function form is given, the solution of the model should look like this. The current consumption C is equal to a linear function of wealth, WE. The hypothesis leads to a consumption smoothing feature because the permanent income is always less sensitive than the current income. In contrast, the Keynesian consumption equation, which you have learned in your first year and A-level, assumes a fixed propensity of the current income. So, in Keynesian models, current consumption C is a linear function of the current income, Y, rather than the permanent income, WE. The Keynesian models therefore tends to predict a higher consumption volatility. Finally, let's look at the effect of the interest rate, R. The interest rate is effectively the price of consumption in the sense that if you consume 1 unit of current endowment, you essentially give up 1 plus R units of future consumption. There are two types of consumers in the credit market, the lenders and borrowers, so the effect of interest rate differs for them. Let's first look at the lender. When interest rate R rises, the budget constraint becomes steeper. The optimal choice shifts from point A to point B, resulting in a higher indifference curve. Therefore, the lenders are winners. This effect can be decomposed into a negative substitution effect from A to D and a positive income effect from D to B. The intuition is that a higher interest rate means a greater interest income for lenders, so they become better off. Now let's turn to the borrowers. When interest rate R rises, the budget constraint becomes steeper too, and the optimal choice shifts from point A to point B, resulting in a lower indifference curve. Therefore, the borrowers are losers after this change. This effect can be decomposed into a negative substitution effect from point A to point D and a negative income effect from D to B. The intuition is that a higher interest rate means a greater interest payment burden for borrowers, so they become worse off. Today we introduced a simplified version of dynamic model in the new classical RBC tradition, which is a micro-founded model in a competitive market. This two-period model can explain many features of volatility and cyclicality of the credit market by the supply-side fluctuations. The changes in endowment can be temporary or permanent, and the welfare effect of interest rate changes can be different for lenders and borrowers. Please read the relevant chapter of the textbook and try to do the self-tests. Have fun!